All right, so we are going to learn about fractional exponents and radicals now. So all of the radicals that we have dealt with up to this point have been just plain and simple radicals like this and like the square root of 4. So there wasn't anything else wild going on in there. Now, if we look here, we have some stuff happening. We have that 1 and 1 to the power of 1/2. So if I was to maybe plug this into my calculator, I would see that this equals 1. If I went 4 to the 1/2, I would see that equals 2. If I did 9 to the 1/2, I would see that equals 3, 4, and 5. So if we're trying to think about what the exponent 1/2 means, that's really the same thing as saying the square root of something. I was always told, and this is kind of a funky way of thinking it, is whatever's in the denominator goes in the notch. So if we're looking ahead and we're thinking about that, 1 to the power of 1/3 is 1, 8 to the power of 1/3 should be 2, 3, 4, and 5. So the exponent 1/3 really should mean the same thing as the third root. These are all just different representations of the same thing. So that is kind of the rule that we're going to deal with. If we're going to evaluate these powers without a calculator, which is totally possible, by the way, now that we know that 27 to the 1/3 is really the third root of 27, we know that that should be 3. The square root of 0.49 should just be 0.7. The cube root of 64, negative 64, should just be -4. And this, please remember this from grade 9 math, this should distribute to each of these terms. So it's 4 to the 1/2 over 9 to the 1/2, which is the same thing as saying 2/3. If you want to rewrite these powers into radical form, into exponential form, I kind of gave you a hint of what I was doing there before. So if we look at A, it's 40 to the 2/3. What I said before is the denominator goes in the notch, so the index. The power can either go here or here. So what does that even look like? That's the real question. So the first way it would look is the cube root of 40 squared, or the cube root 40 all squared. It doesn't matter which way you do it, you will get the same answer in the end. If we look at B, we need to write the square root of 3 to the 5 in exponent form. So that should look like 3 to the 5 over 2. Remember, this goes in the notch, and this is the power. And the cube root 25 squared changes to 25 to the 2/3. Okay. Evaluating powers with rational exponents and rational bases. The first 3, you do not need a calculator to do them. You can if you want, but. So if I'm looking at this, I need to 3 over 2. So I can cube it first, or I can square root it first. I'm going to square root it first. So then it will be 0.02 cubed. And then that'll leave me with 0.008. No, that's one too many zeros. Sorry. There we go. I just checked myself. That should be one more 0. Good to go. Okay, so then 27 to the 4 over 3. If we plug this into our calculators, or the first thing I would do is I would cube root it. So then it's 3 to the power of 4, and I know that one is 81. If I look at C, I have negative 32 to the 0.4. Remember, 0.4 is the same thing as saying 4 over 10, which is the same thing as saying 2/5. So negative 32 to the 2/5. The fifth root of 32 is negative 2, and then negative 2 squared should give you 4. Last one, you do have to plug into your calculator. It will not come out exact on an exam or anything like that. I would tell you if that was the case. So this just equals 2.2770. We're going to apply really quickly. Biologists use the formula B is equal to 0.01 m to the 2/3 to estimate brain mass, B kilograms of a mammal with body mass, m kilograms. Estimate the brain mass of each animal. A husky with body mass of 27 kilograms. So B is equal to 0.01, 27 to the 2/3, 0.01 multiplied by 27 cube rooted is 3, multiplied n squared is 9, which does give us 0.09. Body mass, brain mass, kilograms. B. We get B is equal to 0.01 bracket 200 to the 2/3. Plug this all into your calculator because it's not going to come out exact. You get 0.34 kilograms. Okay. That is your assignment down below. If you have any questions, post them on the Google chat. If you have any concerns about the notes, please let me know.